What is the Doppler effect? We've all heard it, the rising and falling pitch of a car as it zooms past. That sudden drop in pitch is what we call the Doppler effect. Now, imagine if light moved slowly enough for our eyes to detect this shift too. As the car sped by, it wouldn't just change sound, its color would visibly shift. But light travels far too fast for that. Unless you look at the cosmos. Take galaxy GSZ 13, for example. Its true color should look one way, but what we actually see has been stretched all the way to red. In fact, it's been redshifted so extremely it's now invisible to the human eye. This shift in light due to motion or distance is the Doppler effect in action. For light, we call it redshift, and in this video, we're going to explore how redshift helped us discover one of the earliest galaxies in the universe. Stick around, we're also giving away an epic LEGO Space Shuttle set at the end. James Webb's 13 billion-year-old snapshot. That faint red blob you're looking at? It might not look impressive, but it's the farthest object humanity has ever seen. This image takes us back 13.6 billion years, to when the universe was just 2% of its current age. Yet strangely, the galaxy is now over 33 billion light-years away. How is that possible? Light travels 1 light-year per year, right? So shouldn't it only be 13 billion light-years away? Here's the twist. Space itself is expanding. As light made its long journey toward us, the universe kept stretching, dragging the galaxy even farther away. So while its light started from 13 billion light-years out, that same galaxy is now over 33 billion light-years from us. Why do galaxies change color? So how do we measure these vast distances? The key lies in color. Light is made up of waves, and each color has a different wavelength. Our eyes can only detect a tiny sliver of this spectrum. When a galaxy's light appears redder than expected, something has stretched its waves. Just like the sound of a car changes pitch as it drives away, light stretches into longer, redder wavelengths when an object moves away. This is redshift. Doppler versus cosmological redshift. But not all redshifts are created equal. There are two kinds. Doppler redshift, caused by a galaxy moving through space. Cosmological redshift, caused by space itself expanding. Imagine a stationary galaxy. Light leaves in all directions at the same speed. But if the galaxy is moving away, the light waves behind it stretch out, changing color. Here's the thing. Everything in space is already in motion. Our planets, stars, and galaxies are all moving. But those speeds are tiny compared to the speed of light, so Doppler redshift alone can't explain extreme distances. Now consider this. GSZ 13 went from 13 to 33 billion light-years away. That implies motion faster than light, and that's only possible if space itself is expanding faster than light can travel. Confusing? Maybe. But to grasp this concept, even kids can start learning the basics of space. Thanks to our sponsor KiwiCo. Big Bang and the Expanding Universe. Since the Big Bang nearly 14 billion years ago, our universe has been expanding. But unlike an explosion from a single point, there's no center. Wherever you are, it feels like everything is expanding away from you. It's not that galaxies are growing, the space between them is. On average, the universe expands by about 70 kilometers per second for every 3 million light-years of distance. So the farther something is, the faster it moves away. This is why GSZ 13 appears to be retreating at 700,000 kilometers per second, far faster than light. But don't worry, nothing is breaking physics. It's not the galaxy that's moving faster than light, it's space that's expanding. Think of it like chocolate chips in cookie dough. As the cookie bakes and the dough expands, the chips move farther apart. Not because they're moving, but because the dough between them is stretching. Why some light will never reach us? Here's a cosmic bummer. Light being emitted right now from some distant galaxies may never reach us. Because the universe is expanding faster than light can close the gap. So how do we measure how far away something truly is? Even though stars and planets don't stretch with space, light does. As it travels, space stretches it, pushing it into longer, redder wavelengths, and sometimes into the infrared. That's where the James Webb Space Telescope comes in. It was built specifically to detect infrared light, and it just barely caught the ancient signal from galaxy GSZ 13. How James Webb measures time. So how did James Webb find it? It focused on a tiny section of the sky called the ultra-deep field, an area no bigger than a coin held 18 meters away, yet packed with over 100,000 galaxies. To narrow down the targets, scientists used the Lyman break technique. Light below 90 nanometers is absorbed by hydrogen, so any drop-off in that range means light has been redshifted. The more redshift, the further away the source. Webb found 4 galaxies with dramatic drop-offs shifted into the mid-infrared range. Among them, GSZ-13, the most redshifted object ever discovered. How redshift reveals distance. So how do we calculate the exact redshift? Each element in the universe absorbs light at specific wavelengths, leaving behind a spectral signature, a sort of fingerprint. As light travels and stretches, this fingerprint shifts too. By comparing where it should be versus where it ended up, scientists can calculate a redshift ratio. That ratio, combined with what we know about cosmic expansion, gives us the travel time of the light, in this case 13.6 billion years. Remember, early on there was less space between us, so the rate of expansion was slower. Now, with more space there's more stretching, and galaxies are racing away faster. The limitless unknown. Perhaps the most astonishing part of all this isn't just how far we can see, but how much we never will. We debate whether life exists on Mars, but considering how much of the universe we'll never reach, it feels inevitable. Life must be out there somewhere. Giveaway time! And now for the Primal Space giveaway. Congrats to Kurt Bryson, our last winner. In our next video, we're giving away a LEGO Space Shuttle set. To enter, sign up at the link below, like this video. Leave a comment. Do you believe there's life beyond Earth? Thanks for watching, and I'll see you in the next one.